Hey guys, here's a video walking through number 8 from the homework. A lot of people have messaged me saying they got stuck on this one. There is a video I'd already uploaded the other day that dealt with the semicircular cross sections, so I would recommend watching that one if you had trouble with part C. But I'm going to walk through at least parts A and B in this video, and then we'll kind of see how it goes from there. So in order to do that, we just got to recognize what equations we're dealing with. We have y equals x squared, x equals 1, x equals 4. All three of these, the cross sections perpendicular are to the x-axis. So I'm going to go ahead and focus on that. The first one is a square. So let's go ahead. I kind of already set it up over here a little bit. First thing we want to do is definitely get a good picture. So y equals x squared. That's a classic. There's y equals x squared from x equals 1 to x equals 4. So let's just say something like this, from x equals 1 here to x equals 4. So this is the region we're dealing with, okay? But again, we're not revolving this region over the x-axis. We're literally slicing down towards the axis, and we're getting squares with every slice, because part A, cross sections, it said, were squares. So all we really need to remember when we do these volume problems that look like these is the volume is going to be the integral of the area of the cross section. Okay, so all the examples we did prior, the areas were always circles, so we always had pi r squared for all those problems. But in this case, the cross sections are squares. So the area of a square, of course, is just side times itself. We just got to figure out what the length of one of the sides are. Okay, refocus real quick. So this piece right here, this length between the curve and the x-axis is the length of the side of a square, and it's kind of coming out at you three-dimensionally. So all four of these sides are the same. Okay, think of like a loaf of bread, like a really odd-shaped loaf of bread. But if you were to cut down that loaf of bread and look, inside, you would see little square cross sections. Okay, so we just need to figure out this length. Well, this length is the function in this case. So the side is x squared. The distance from the x-axis up to the curve is x squared. The distance from the plane, coming out at you is x squared. So this distance here, is coming out at you the same length. Okay, so this distance vertically would be exactly the same. So then the volume is just going to be the integral from 1 to 4 of the side, which is x squared, squared. And that's it. That's how you would set that up. It almost seems too simple, I know, only because the area of the cross section is a simple formula since it's just a square. So the hardest part about these is not necessarily just doing the formula for area of a square, but realizing that you're not revolving this region. The region is the base of a solid. Solid is literally sitting on top of your paper right now. Okay, so to finish this one off, I'm going to go ahead and use the calculator. This would be a good time to practice one of the online apps or your phone if you don't have one of these calculators. So math 9 from 1 to 4 of x squared squared. So that's really just x to the fourth, right? dx. So that's going to be approximately, actually it looks like exactly 204.6. And that one would be done. Part B, basically the same kind of problem, but part B said that the cross sections are rectangular where the height is 2 times the base. So actually I can use the same picture. Let me scroll down here. I can use the same picture. I'm just going to go out twice as far. So your cross sections, I can't really use these pieces anymore, but I can say that's the same, and these two are the same. And if I remember right in the directions, it said that the height is twice the base. Height is twice the base. Well, what's the base? That's the x squared. That's the same base as it was for the square cross sections. So then the height is twice that. So this is essentially a rectangle where the base is x squared and the height is 2 times x squared. Okay, so to find the area of the square, or the rectangle in this case, you would just do your base times height. So the area is base times height. And then the volume is going to be the integral. The volume is going to be the integral of x squared times 2x squared dx from 1 to 4. Okay, So, you could simplify that. I'll do it up here so I can just keep it on the same page. This is going to be from 1 to 4, 2x to the fourth. And now we can go ahead and solve that in our calculator. And I could basically just do the same thing, but it's going to be 2x to the fourth. And I get 409.2. Okay, so the key to these problems, again, is really just recognizing that the shape of whatever that cross section is essentially the formula you need to integrate. That's basically what this original formula came from when we first learned about it. All right, so hopefully that helps. Try retry number 8 on your own, maybe. See if you can get it to work. And also, if you want, try some of those extra practice problems I posted, because you'll find some of these in there as well. And if you need any more help, be sure and let me know. And I hope everybody's doing well, and I'll hopefully see you soon.